Hello and welcome back. Today we will talk about some rules of differentiation. The last time we talked about the rate of change and its geometrical interpretation, how we use it to obtain the slopes of the functions. Today we will have some rules of differentiation, and actually this rate of change can be called a derivative. And we call it a derivative because it's derived from the original function, and it's referred to as f dash x or y dash because the original function is fx or y. So we add a dash here to refer to the derivative. So this derivative actually is the rate of change of the function. We have some rules of how to obtain this derivative. The first rule is if our function is constant equals a, there's no variables, there's no x here, so our f dash x equals 0, and we will prove it now. We know that the f dash x equals the limit of h approaching 0, and here we have fx plus h negative fx over h. So here actually there's no x at all, so we will type a negative a over h, so it yields 0. So instead of writing these steps, when we see fx equal a certain value, constant, and there's no x here, we type 0. The second rule is if we have fx equals x or a x of power n. So at a x of power n, the f dash x will equal n a x power n negative 1. So this is because in the limits, as we mentioned before, if we have the lim x approaches 0 and we have here x of power n negative a of power n over x negative a, so the result here is n a n negative 1. This is the same way. Here we have function of a x n. We drop the n downwards and subtract a 1 from it to give f dash x n a x of power negative 1. We will have some examples to show how these rules work. For example, if we have fx and here we have x to the power 2 negative 2x positive 1, and we want the derivative of this function. So in this function we have 3 terms. We can deal with each one of these terms as a definite function, applying the rules that we have new now, as if this is a function and this is another function and this is a third function. So here what we will do is dealing with the first term, because they are added to each other or subtracted from each other. But if they are multiplied or divided, they have another rules that we will talk about the next time. So this x to the power 2, we will apply the rule now. We drop the 2, keep the x, alright, and here we have 2 negative 1 gives us a 1, so we do not write any power. The next term, we will write the negative, then we have 2x. This x is of power 1, but it's not written. So we will drop the 1 downwards, and 1 by 2 equals 2, of course. And 1 negative 1 gives us a 0. 2 yield an x of power 0, and x of power 0 gives a 1. So we omit it. This is our second term. The third term is plus 1. And the 1 here represents the a. There's no variable here. So at once we type 0. So the derivative of this function is 2x negative 2. We get the 2 outside the brackets to have 2 bracket x negative 1. This is the derivative of this function. And this is how we apply the last two rules that we mentioned, because the items here are added to each other. They are not multiplied or divided. The multiplication and division have certain rules we will mention the next time, and until then I thank you for watching and see you next time.